Let's do this. All right. Thank you, everybody, for coming to our cyber attribution webcast. We have Jason on, we have CJ on, and I'm sure that there's other BHIS people on. We also have Chris Breton on, and we've got an announcement here at the end of the webcast. We'll be sharing that with you at the very end of the webcast. But I wanted to do a webcast for two reasons. One, I wanted to talk about cyber attribution because it's came up in a couple of different articles that I've read and a couple of additional presentations from other people. And I wanted to address this concept of cyber deception and how you can actually implement it very, very, very easily. And we're going to be spending a lot of time talking about some free tools from Thinkest. They have the Canary Token web server, which is amazing. You should all check that out. It's really, really, really super cool. So without further ado, this is brought to you by Black Hills Information Security. We do pen tests. You need a pen test? We do those. We should hang out. So give us a call, send us an email at consulting@blackhillsinfosec.com. And we'd love to chat about your red team web application assessments, black team, and also cyber threat hunting needs, because that's what we do. It is also brought to you by AI Hunter, and that's the big announcement that we have at the end. I'm trying to keep as much of the vendor crap at the end of the webcast as possible, but if you would like a demo, just type in demo or script alert document.cookie close script or apostrophe or 1=1 into the questions box. If you type any of those in, one of two things is going to happen, maybe three. One, you will get an email from us and we'll set up a demo where we can show you AI Hunter. The other thing that we might do is just, do a security assessment of GoToWebinar in the middle of the webinars, because God knows that GoToMeeting and GoToWebinar love it whenever we start doing tests of their input boxes in the middle of our webcasts. It's also brought to you by the Cyber Deception Active Defense Hacking Back class that will be at Black Hat USA 2019 from August 3 through the 8th. So check that out. It's going to be over my birthday. Everybody that comes to the class gets a free book, gets a shirt, gets a USB stick that I'm actually mastering right now. That has all the different tools and all the slides and a lot of the stuff that we're talking about here. To be completely honest, is me updating the slides and just doing it free as a webcast. So I just completely have a whole bunch of people now that are like, well, I'm not going to just going to do it for free. There's no reason. It's a great time. It's Vegas, so check it out. So let's jump in. So time for a little bit of a larger conversation whenever we're talking about cyber attribution and cyber deception. One of the things that I run into quite often is a large number of people that are InfoSec thought leaders, and I'm not using that as kind of like a joking phrase, because Brian Krebs is an InfoSec thought leader. Jeff Moss is an InfoSec thought leader. And you could even argue like Bruce Schneier still is an InfoSec thought leader, even though now people are going to flame me and be like, of course he is. But at any rate, you get into these larger conversations about newer technologies and newer concepts. And I think I suffer from this as well, where you see something new and you immediately want to poop on it. And there's a number of reasons why people react this way. One, a fundamental lack of understanding about the technological concepts. Let me give you an example. If you're looking at like cloud, right? And Chris Breton is on, and I'm going to credit him with this. Cloud computing, for the longest time in the industry, was referred to as, well, that's just simply somebody else's computer system. And you're going to put all of your data out in the cloud, and that's somebody else's computer, and that seems like a bad idea. And I still think it is, for all intents and purposes, a bad idea. But Chris was one of the first people, when he was at Cloud Passage, actually, that really drove home the idea that no, this is absolutely disruptive. This is going to fundamentally change the way the industry works. And a lot of the jokes that I used to tell, especially in my classes and presentations, as soon as I started talking with people that I respected, I realized that I was kind of lashing out at new things, and I was doing it from a place that I didn't understand it. And it's easier to put something down than it is to actually try to understand that technology. So if we're looking at things like blockchain, that would be another great example. Or if we're looking at cyber deception technologies, I think that that's another great example as well. And if you look at these quotes, right, like if we actually drive into Brian Krebs talking about deception technologies, but advisable only if your organization is doing 99% of the rest of basic security. And I think that that's wrong. And I'm not saying, hey, Brian Krebs, you're an idiot. That's not true. A tremendous amount of respect, because, he could crush me like a bug. But going further, I think that that's driven in a large part to a lack of understanding about the technologies. And Jeff Moss, whenever he was at Black Hat Europe, he got up and he was talking about cyber deceptions, and he said that there was an apparent lack of use of deception technology. I have never heard one speaker say, and then I checked the canary, or then I reviewed the deception tech, and who here uses deception technology? And there's like one person that raised their hand. And once again, I feel like that's a mistake, right? Just because a lot of people aren't using a technology doesn't mean that that technology does not have merit. We have been doing a large number of assessments, and recently, especially recently, we've been seeing a large number of our customers that are starting to use deception technology. And I wanted to have a webcast to tell you it works, people. It does. It just changes based on how we look at it. So if you're looking at like Cuthbert, he had a quote. He said, deception technology poses many problems. As an ex-attacker, if you breach the network, you go for the juicy network, he said. In addition, for an administrator standpoint, the moment you throw deception tech on there, you have 4 networks, and it's an overhead nightmare. And I believe that a lot of this is based upon an understanding of deception technology that is 10 years old, that people believe that it's a series of honeypots. Like you're going to stand up a Windows 2000 box and you're going to try to sandbox it. You're going to try to log everything the attacker does and try to set up breadcrumbs to have the bad person go to that computer system. And it's a lot of work. But even if we look at Lance Spinster's book, whenever he was talking about honeypots years ago, he was already trying to break the conversation into high interaction and low interaction honeypots. And high interaction honeypots are what most people think of as honeypot technologies, something that takes a tremendous amount of effort to actually implement properly within their organization. Today, I'm going to take one small slice. I've got a 4-day class dedicated to this topic. We're going to take one small slice on cyber attribution, and we're going to talk about low interaction honeypots and technologies that you can easily implement in your organization. And you don't have to have a tremendous amount of overhead nightmare to actually do it. It is something that you can implement very quickly and very easily in your environment. So I want to pause, take a breath. Jason, do we have any questions so far?
Just one comment. People may not raise their hand to deception questions. They don't want to let people actually know they're using it. Any thoughts on that?
I would agree with that. I don't think that's what's happening in the black hat situation. I do know that by and large, people don't like raising their hands, especially computer security people. We aren't big into, all right, everybody, let's stand up and clap. All right, let's do some jumping jacks. Let's get in the zone. No, we generally don't do that really well. We aren't sweating to the oldies. I can't remember the guy's name that did that, but we aren't big into
Richard Simmons.
Richard Simmons. Yeah, we aren't really big into that group exercise type thing. But no, I would not believe that people are, well, I'm not going to raise my hand because then they know I'm using deception technology and then I'm outed. And somewhere in the back of the room, there's going to be a hacker and he's going to see me and he's going to know that I use deception technology. I don't think that's the way it rolls. I do believe it's not nearly as implemented as I would like to see it implemented. There's a bunch of great companies. Symmetria, Gadi Everon's company is amazing. You got Elusive Networks, TiVo, and we're going to talk more about Thinkist a little bit later. All right, so why are we talking about this? So another useless rant by me on threat intelligence feeds, and I probably need to stop this because a lot of organizations are now implementing threat intelligence feeds in a lot more intelligent fashion, rather than saying, well, here's the Cyber APT 22 group, and this is what they did 4 months ago, so they're gonna do that again. Instead, with the MITRE ATT&CK technique matrix, we now have this great collection of different types of techniques that adversaries will use. And instead of just trying to find one type of adversary path, we're now collecting all of them and checking for all of them. And I think that there's value in that because there's a tremendous amount of overlap in the techniques that are being used. But I want you to think about what is the goal and the objective of a threat intelligence feed. The goal and objective of a threat intelligence feed is to understand adversaries. And I think that that feeds a very base need in this industry where a tremendous amount of what attackers do is black magic, right? So what a hacker does, well, that's got to be black magic. How do they bypass antivirus? How do they get spam inside of our network, bypassing our anti-spam protections? How do they move laterally? I don't know. But if we purchase the threat intelligence feed, then maybe our computer systems will, develop a better way of understanding it. And I think that gets to a very base desire. We want to understand what attackers do. And that's one of the reasons why we do so much at Black Hills Information Security in the form of webcasts is we're trying to demystify the cult of the hacker. And I know that that seems weird because I self-identify as a white hat hacker. I love what I do for a living, but I can't stand it whenever people are like, well, this is super elite and you probably wouldn't understand it. And there's only like 1% of the human population that's ever smart enough to figure out what I know about writing an exploit, which is total garbage, right? So we're trying to demystify that. We're trying to basically bring as much understanding as possible about the offensive capabilities and the defensive capabilities that'll counteract them as well. So we need to understand attacks, but how about this? With deception technologies open up the ability for you to understand attacks and attackers that are attacking your network, not a technique that was used against another unnamed company 3-4 months ago or a year ago or 6 years ago, but what's happening right now in your organization. And I also think that if we take this idea, right, of being able to get better attribution of adversaries rather than looking at their TTPs and saying, well, they used this malware and we found Hebrew in it, so therefore it's clearly Israelis. There's no way this would ever be a Russian or somebody from the CIA or the NSA that would put Hebrew in their malware to make it look like another nation state. There's no way another nation state or organized crime attacker would try to make their malware look like someone else, because that wouldn't work, right? No one can think about that. But if we can start tracking real adversaries against our network, things change. They change in a variety of different ways. One of the major ways is psychological. You've heard me mention like Jerry Bantham and how people regulate themselves whenever they believe that they're being watched and monitored. And there's some really messed up crap with that. One of the theories that's interesting is the theories of broken windows. And the theory is this: if somebody is inclined to crime, and they're walking through a neighborhood and they see a whole bunch of graffiti and they see broken windows, then they believe from their environment that they are witnessing that this is a safe place for them to commit crimes, because there's a lot of crimes happening and there doesn't seem to be a lot of people stopping crimes from happening. So therefore I can commit more crimes. This is really, really controversial in a large number of different ways. Rudy Giuliani, I think, was one of the first people that implemented it in New York City, and it set off just a firestorm because he was promoting things like stop and frisk, and then that got into racial profiling, and that got into all kinds of additional nightmares as things happen whenever you're doing sociological studies. There's all kinds of evil things that break into it. But the core of this premise, whenever we're looking at broken windows, is if an adversary sees crimes and they don't see a lot of criminals getting caught, then they're more likely to continue committing those crimes. So if we had a situation where more adversaries are caught using these technologies, and I don't mean detected, I mean literally caught and put in prison, then that would drop the overall amount of cybercrime, because right now it's relatively easy to launch attacks at organizations and not get caught. So this also feeds into that broken windows. And here's the beautiful thing: you don't necessarily have to catch people, but the more of us that are having conversations about cyber deception, the more presentations talk about this as a topic, the more people that listen to these webcasts, they start to think, well, holy crap, if I'm attacking a network, there might be some deception technology in play, and they might actually catch me. They're less likely, far less likely, to actually do that type of attack. So I want to pause again. I'm trying to get better at pausing up the slides. Jason, any comments or questions from the audience?
Got this one. Say your entire org is on Microsoft. The only real assets are mobile devices, laptops, etc. Perhaps very little data exists on the endpoint. Other than forcing canaries, what suggestions would you have?
So whenever you're looking at that type of architecture, and that's getting a little bit off topic, but I think it's a very important topic, right? There's still a lot of people that are like, well, what about malware on phones? What about malware on phones? As I'm doing this, all of a sudden my phone starts like, yeah, whatever, starts buzzing. So whenever you're trying to attack those devices, understand that they're ultimately tied back to a cloud service. If you're looking at Android phones, they're almost always tied to Google. If you're looking at Apple phones, they're almost always tied back to Apple. So whenever you're attacking a device, it's now far less interesting to get malware on the device itself. And it's a lot more interesting to get access to the cloud service. So you can still use these tokens, and we'll talk about that because it still applies in some scenarios. Like if we're talking about executable tokens or canaries, or if we're talking about documents, you can put those in shared folders as well. So it's the same concept. It's just you're moving where those canary tokens would actually be in order to actually get better attribution. So if I'm boiling that question down to one simple thing, don't look at the endpoints, especially for mobile endpoints, as much as you would worry about the authentication portals, user IDs, passwords, two-factor authentication, to gain access to the resources that the mobile devices gain access to. Because if I gain access to your Google account, I also have access to almost everything on your Android device as well. Any other questions, Jason?
There was one on hacking back, which your question is, watch your legality.
Absolutely. You know, what we talk about hacking back in the class, and it boils down to simply get a warrant. As soon as you start talking about getting persistent access to a computer system, not signaling, not beacon back technologies, you're probably violating the law. And we'll talk about that. And everything we're talking about here is attribution. We're not getting persistent access on a computer system. We're just going to have these various tokens beacon back. And we'll talk about how they beacon back here in just a few moments. So I'm going to move on. So getting started, canary tokens. I used to have all kinds of different things where I would talk about different technologies, and then Thinkist brought in this great website, canarytokens.org, and you can all play along with me live. And I can't thank them enough for this because it is absolutely fantastic. So I'm going to break out of my presentation, and I am going to go to Canary Tokens. And we'll give you a quick overview of what it looks like. All right. So we're going to be going through a number of these tokens, talking more in line of use case scenarios and what it looks like when they trigger. But every single one of these tokens are things that beacon back. Now, by and large, the vast majority of them beacon back in very, very basic ways, and there's very good reasons why they want those tokens to beacon back in very, very simplistic ways. And we'll talk about that more here in just a little bit. But we'll be discussing a large number of these, and I'm also going to be bringing in ADHD as well. And you can get ADHD from our website. We're going to be moving ADHD over to active countermeasures because it fits far more with the active countermeasures umbrella than the Black Hills Information Security umbrella. It's quickly becoming active countermeasures as the defensive arm of what we're doing at Black Hills InfoSec. So we'll be using both of these throughout the rest of this webcast. So let me go back to the presentation. So awesome, because everything that we can do that I'm going to talk about, y'all can do with me. And we're probably going to end up DOSing this page just because we have so many people using it. I hope it doesn't do that. But it'll be great for us to kind of discuss conceptually how each of these different tokens can be implemented. So I already mentioned ADHD, the Active Defense Harbinger distribution. And the Active Defense Harbinger distribution, I'll cover up my face here. That's just weird. There we go. One of the cool things about ADHD is it has the capability for you to very quickly implement it. You can download it from our website at Black Hills Information Security. It's under projects. And all of the tools that we discuss, every single one of them are actually in ADHD with step-by-step instructions on how to use each of them. So we'll be talking about some of the tools like the web bug server, which I've talked about quite a bit. We also have a local instance of Canary installed because the Canary project is open source, and how to use Canary live. We also have Rita installed on it. But we have a lot of technologies that we have thrown into this, and it has step-by-step instructions on how to use these technologies. Because remember, my goal in all of this is to desperately try to get more people using cyber attribution and cyber deception technologies, and trying to make it as easy as it is as possible to get people to use these. And whenever possible, I have little videos set up that you can watch me walk you through how to use it. So yeah, a lot of work went into this, and we're going to continue to update it over the next year. I think that we're going to move it over to active countermeasures because this is a project that we believe in. All right, so let's talk about recon, right? So if an attacker is trying to break into your organization, they're going to go through the recon phase first, right? They're going to go through that particular phase and try to enumerate as much as they possibly can. We'll probably have another webcast that isn't so much attribution, but we'll probably discuss deception. So how do we annoy the attacker? How do we greatly increase the amount of work effort and do it in such a way that it's easy for us to do. It's very quick to implement, and it greatly increases the work effort for the attacker to try to break into the organization. But right now in this particular webcast, we are focusing on attribution. So how can we take advantage of an attacker trying to perform recon against an organization and then possibly gain some idea of where that attacker actually is? So every single attack methodology that's out there, whether you're using the NIST framework for doing cyber assessments or you're using PTEST, penetration testing execution standard, they're all going to be using some form of recon in order to gain as much information as they can about your organization. So before we get into it, I want to pause again. Do we have any questions or comments, Jason?
So one was just what is unique about ADHD?
What is unique about ADHD? Wow, I feel like that's like a job interview question. It's like, so
Yeah.
because I'm awesome. No. So if we're looking at the reason why I think ADHD is unique is because of the usage that we put in. Originally, ADHD was a DARPA-funded project in conjunction, believe it or not, with Secure Ideas. We worked with Kevin Johnson on the first iteration of this, and it has all of these different tools built into it. And like I said, we have all the step-by-step instructions built into it. We break down across the top. We got the annoyance tools. So all of these tools exist in ADHD, and we'll be talking about a lot of these tools in further webcasts as well. Like here's one of my favorites, port spoof. If we're talking about easy deception technologies, this is a technology you can implement that basically says that every single port is open on a computer system, and it pulls a random fingerprint for that service and throws it back at the attacker. So it looks like every port is open with a valid service. That's cool. And this gives you step-by-step instructions to actually get that set up and running. Web Labyrinth, okay? If we got Web Labyrinth up and running on a server, we can break web application crawlers whenever they go through and try to enumerate all the directories. Every single hit that they hit brings up another randomized bit of text from Alice in Wonderland, and it will break any of the crawlers that exist. So two things, the tools are installed and they work. And the other thing that is really, really important is step-by-step instructions to make it super easy for anyone to use it. So I hope that answered the question.
And how much does it cost again, John?
ADHD is free 90 free. Costs absolutely nothing. And you can get it for now. You can get it. I'll show you where to get it here in a second, but it's at blackhillsinfosec.com. All right. So let's talk about AWS keys, right? So attackers love going to GitHub repositories. They love going through a website to try to identify AWS keys. And we have all kinds of examples where predominantly security researchers are going out online and they're trying to find these different keys. So here, I got these slides out of order. So here's some context, right? So I would say it's about once every other week, there's a new security researcher that has a big article. They're like, the security researcher did tons of analysis and they identified that all of these very large companies had directly exposed AWS containers with all of the sensitive data. And it's like a big deal, right? It like shows up on the news and I get calls at IONS and I have students that are freaking out on this. And yes, attackers are actively looking for exposed AWS keys. So what the hell? Let's give them some, huh? So what you can do in Canaries is you can go here and you can say, well, I'm going to generate some AWS keys and I'll put in an email address and put in that. And then I'll put in something like a trigger warning. Yes, it also helps to spell warning correctly. And I'm going to put in strandjs@gmail.com. And now I can generate my token like so. And now my token's created. And there's my AWS keys. And I can load those AWS keys into any number of different tools like S3 Explorer. You can put it on GitHub and put it in places that you might have code repositories, open source projects by your team, whatever. And you can put that out where any attacker that's actively trying to do a search for AWS access key ID can find that. And an attacker or a cybersecurity researcher will see that and they'll be like, hooray, we've won. But the problem is, if the attacker actually runs it, where's my AWS keys? So here's all my Canary tokens that we have. That's assigned executable. We'll come back to that one. HTTP, that's word trigger. you will actually get an email from the from Canary Tokens, and you can set this all up on your own server, where whenever it fires, it actually will show somebody has actually accessed that AWS instance or tried to use those keys, right? So this is an awesome way to very quickly identify an attacker that is trying to break into your system. And once they have used that AWS key somehow, then you get a wonderful little alert that you have now gotten the IP address of whoever it is that's trying to access your servers. So yeah, right in the middle of the recon phase, if I can get back to why this keyboard is not working, there we go. If we can get into the attacker's like attack cycle right at the beginning, whenever they're doing recon, it makes it super easy for us to see something like this, right? So the token reminder is AWS. The Canary token has a randomized string and AWS keys. Now I really like, it gives you the source IP address, which is cool, but it'll also give you the user agent string. And you can see in this user agent string, it said S3 browser. So the attacker was trying to use S3 browser to access this particular S3 bucket. And there's the IP address. Now, it's not doing latitude and longitude. And yes, attackers, whenever you're dealing with IP address, it's not super hyper accurate. But if you have somebody that's broken into your system or is attempting to break into your system, and you have the IP address and the date timestamp associated with it, it becomes a lot easier with a warrant to go to an ISP and actually get directly where that particular IP address is. The point on that is a lot of ISPs have far more accurate geolocation information than they expose to the open internet. So there, just a little bit of recon makes it a lot easier. And I'm still looking for the day where I'm thinking about creating a bunch of these, setting them out, and hopefully ensnaring some security researchers that go public. And they're like, well, we hacked into Black Hills Information Security and we gained access to all of their reports. Here's one of their customers, Mickey Mouse Enterprises. And, you know, all of a sudden it's on Decipher, which, by the way, Decipher has the worst color scheme of any website known to man. It's just absolutely hideous. So any questions on that, Jason?
Just one, do alerts only go to an email address?
Yes, unfortunately, whenever you're setting this up, especially from the Canary Tokens website, it will just send you an email. However, they have the entire source code available and we have it loaded on ADHD, and you could conceivably easily set that up to where it would generate alerts to something else like syslog. Cool. Any other questions?
You never mentioned Azure, but we assume blob keys. Same issue, same Canary concept?
You could do the exact same type of Canary concept. It's just it has not been implemented in Canary tokens. So we're using Canary tokens really as kind of the tool to demonstrate the capabilities of what you could do. So yes, you absolutely could set that up as well, where you would set up that different instance, and when somebody tries to use it, you could get an alert as well. And once again, this isn't hard to do, right? If we're looking at Canary tokens, it took me like 3 seconds to generate one. It would take a little bit more time to implement the entire Canary tokens infrastructure on your own environment, but it is relatively easy to set up. It is relatively easy to create these different tokens, and it doesn't create a tremendous amount of overhead or 4 networks to maintain instead of 1. All right, executables. I love executables. And no, you wouldn't think an attacker would ever run an executable, but if you have the right executable, like if you have a share somewhere that looks like it's enticing, and it says something like VPN config, sysprep.exe. Oh, if you're in a pen test and you find these types of executables, we just get really excited because these become the pathways for us to get direct access to the environment, configuring our system in a virtual machine to have all the software and maybe there's passwords in it, or VPN config. And we can, oh man, we could set up the VPN automatically and then we could start doing password spraying with it. It's just so exciting. And the thing that you need to learn about this, and this is really key, is whenever somebody's trying to break into your system, we usually become idiots. I know that there's some pen testing firms out there that are like, well, we're far more professional and we would never do things like, they're full of crap. Whenever you're pen testing and you see something that thinks it's going to give you direct access to the environment, you go for it, right? We talked about this in the early incarnations of Honey Badger where we stood up Java applets. Yeah, no one would run Java applets because it's old. No, an attacker will. If you have old Java, like if you're running like a VNC on the outside of an environment, you are absolutely going to trick an adversary to run that Java app, right? That's just what we do. By its very nature, it's old. It means that there's security vulnerabilities. And yes, we get so excited whenever we see these. And you are also going to hear about people that say, well, what I would do is I would reverse engineer and completely decompile the executable in order to make sure that that executable was in fact what it says that it was, and then I would not run it directly. Once again, they're full of crap. And this goes into like anytime anything bad happens to somebody, like if somebody's walking down the street and a piano falls on them, inevitably you're going to have some jackass that says, well, that's why I walk down the street like this with my head up in the air, watching constantly for falling pianos and dogs that may have fallen out of windows. God knows Michael Jackson may be around. It might be a small child, and I'd have to catch that child. So I walk looking up at all times. It's kind of this normal human interaction when something bad happens to say, well, we would never do something like that. But they're full of crap. They would. You see an executable, you see something that looks like VPN config, sysprep, you are going to run it. Some attackers may try to run it in a sandbox. That's fine. And some people may try to reverse engineer it. That's also fine. The reason why it's amazing is you can take the canary token and you can backdoor existing executables. So you could literally go and find an OpenVPN config.exe like executable, right? You could download it and then you can quote unquote backdoor it so it has that tracking token inside of that executable. So you can create that custom executable in that binary, put the email for the alert notification, say that it's going to generate an alert that says an exe was ran, and then you can feed it in an executable. It'll automatically backdoor it to have it beacon back. And this is what it looks like. So I went and I pulled down Rufus, which is an ISO burning utility, and I renamed it to Free Candy, once again, sticking with the overall theme. And then as soon as you ran Free Candy, you generate an alert. And it says, well, we got a DNS resolution that came back. We got an executable. It's a signed executable. Here's the source IP address. So that's awesome. Now, is this necessarily hacking back? No. If you're looking at kind of where the line would exist. And I've talked about this, and I didn't put any slides in it because I talk about it a lot. Susan Clements Jeffrey versus Absolute Software, the judge in that particular case, Judge Walter Rice, said it is one thing to have an attacker call back with their IP address or geolocation in an effort to track down stolen property. It is another thing entirely to violate federal wiretapping laws to do so. And that bright line that that judge created in that case was, if we can get them to beacon back, we don't have access to their computer. We're not running persistent access. I don't have access to their files. I don't have access to their browser history. I just made this executable do one ping only to my computer system so I can track where my executable actually is. So this gets into signaling versus content, right? If we can make documents signal, if we can make when somebody accesses an AWS key signal, we are not violating the law in order to do that. And if you think we are, if somebody is actually doing that, I want you to run a sniffer at the edge of your network. And I want you to catalog all the software packages that are running in your environment that beacon back as soon as somebody opens a Word document, as soon as somebody opens a PDF, as soon as anybody runs these different software programs, they're phoning home. That's what they do. And that, if it's illegal, that means that almost every piece of software that you have in your environment is illegal. So once again, that's a line that we should not cross, right? We do not want to cross the line in gaining access to an attacker's computer system. Maybe if we can get that attacker's system to ping back to us, that would be very useful to us as a whole. So how you can actually do this in your infrastructure? Well, robots.txt is amazing, right? So I stole SANS robots.txt because Johannes has just an amazing bunch of like cyber deception built into the SANS robots.txt file. And it says disallow registration, disallow admin page, JSF detect, JSS reg detect, admin email maps, and so on. You can create these directories like an admin directory. You can create an email directory, or you can create a backup directory or a help desk directory. And your standard crawlers like Google and MSN Bot They will not go to those directories. Your standard user population will never go to those directories ever. They just won't, right? But an attacker that's doing recon and trying to come against your organization, they will see these directories and they will immediately go to these directories. And that's where you can give them like a Word document, which we'll talk about here in a second, or an executable that looks like something, and it could actually be a VPN configuration executable that you backdoored with some beaconing technology in it. So it makes it very easy to set it up in your environment. It's incredibly low interaction on your environment, and it is something that an attacker is absolutely going to look for. We can also go further with this, and as I mentioned earlier, Thinkus didn't go as far as they could have, and I'm not begrudging them for it. I'm not saying that that's wrong. They were definitely staying very clearly on the side of the law, and they're not actually moving into some gray spaces. If you want to move in to some gray spaces, instead of having an executable that actually calls back with its IP address, you could have an executable that runs honey badger type techniques, and it could run NetSH WLAN show networks mode BSSID, or you could run IW config or IW list to actually list out the wireless networks on a Linux computer system. But you could go a little bit further and enumerate a little bit more information. Once you get the BSSID, which is the MAC address for access points, you can then feed that information into Google, and Google will tell you exactly where that particular computer system is. And the reason why that's super cool is if I can do geolocation based on MAC addresses or pattern of life for access points that are used, I'm finding out exactly where they are. And even if they're using something like Tor, it doesn't matter because we're actually pulling that blob of data off of the victim system, or in this situation, the attacker system, and it can come to us through Tor. It doesn't matter, but now we have accurate information about where that attacker system is right now. So Jason, any other questions?
A few. Is it possible to get a public IP address when the source machine is hiding behind an NAT?
Yes, absolutely. Whenever that system, the attacker system, and beacons back, whenever it's behind a network address translation device, you're going to get that IP address of the NAT device. That'll be the home router. That'll be like the corporate router. It may not get you the internal IP address of that computer system, but it'll at least get you in a very, very good geographical location of where that attacker system is. Further, whenever you're running the NetSH show networks with BSSIDs, it's not just going to show you the one network, but it'll show you all of those networks. And then based on the signal strength of the relative attenuation of all of those networks and the triangulation, Google will actually give you latitude and longitude with kind of an error. Usually it's between 20 and 40 meters if you have like 5 access points that you can see. The more that you give it to Google, the better it is at telling you exactly where that is. And at that point, it's even better than the internal RFC 1918 IP address. You're now at the point where you can say they're in this large building, in this part of the building, like a dorm room. We've had this in the past where college hackers were trying to break into one of our systems. This is years ago when Tom still worked with us. And we were able to find out there was an attacker in a dorm at Pepperdine University and what wing they were in. So yes, you can get very accurate geolocation doing that. A little bit.
Another question. What is the lifespan of a canary token? Forever?
So from what I've seen so far with canary tokens, I have had canary tokens that have fired from a year ago. So it doesn't seem like they purge that database very often. But what you can do is you can take the canary tokens code using the Active Defense Harbinger distribution here. And you can go to attribution, go to canary local server, and here you go. So you've got the callbacks and how to set it up on your local system. So we have step-by-step instructions to actually do that. This server works a lot better whenever you have it set up on the open internet with a real IP address and a real domain associated with it. In that situation, it's up to you how long you want your canary tokens to last.
One last one. Would beaconing back be comparable to LoJacking?
Yes, it would be very, very comparable. In fact, Absolute Software was a company that actually did LoJack software for computer systems. The reason why Susan Clements Jeffrey won that particular case is the police department and the school system that had that software installed. They didn't just find where the computer was. Like I said, the judge ruled it as one thing to geolocate a computer system and with its IP address in an effort to track it down. Where they crossed the line, though, is they started taking pictures with the camera, and they caught Susan Clements Jeffrey in various states of undress and sexual activity with that camera. So even though that computer was owned by a school, the fact that they were gaining access to this lady's computer system that she had purchased, illegally or not, they were actually breaking the law. So the point to break down is you are not okay breaking the law against somebody that you think has broke the law. Right, I'm going to move on with this one. Cloned websites. I love this one. All right, so if you look at attackers, one of the things that they'll do, we're kind of moving into the attack phase a little bit, is they will clone an authentication portal. Okay, so if an attacker like goes to your OA portal or any type of authentication portal that you have at all that requires a user ID and password, they will use that in a phishing attack against your users, right? I mean, this just makes sense. That's the way attackers do it. Social Engineering Toolkit has the capability of cloning a website, automatically loading malware, or doing credential harvesting on that website. What if we could put a little snippet of code that as soon as the attacker ran something that cloned that website and that new website was stood up, that new website would beacon back and we can say, aha, that IP address over there, that IP address is evil, automatically blacklist it in our spam filters. So you can actually change the domain whenever you're setting up the configurations. The default domain, you can set it up. It's thinkist.com. You can change it to your own domain as well. And you can set it up to your own server. Right now it's going to canarytokens.com, which is kind of a dead giveaway. But if you stand up the Canary Tokens server, which by the way is installed on ADHD for you, you can put in your own domain and then it becomes less suspect whenever somebody actually fires it. So you take this code, right? And it's written in JavaScript and it's pretty straightforward. You can take this code and you just put it someplace on your authentication portal. And whenever an attacker scrapes or clones your website, they take that code, they pick it up, they spool up another web server. And as soon as they spool up that web server, bang, it actually loads and you've now identified that IP address. You can also go through and obfuscate it, right? This is pretty obvious. It looks like, Canary token, but you can obfuscate it, make it a lot more difficult to identify. You will want to change the domain. If you do not change the domain, it's still going to say thinkist.com, and we don't want that. We want that domain to be something that you stood up and it's specifically for your organization, specifically as it relates to doing this type of cyber attribution. So you can obfuscate it, you can load it into your website, and as soon as somebody clones that website, it will actually generate this alert. It'll say the channel was HTTP, here's the randomized name token, somebody cloned a website, here's the IP address of the cloned website, the user agent string. And this was fun. As soon as I sent it through the obfuscator, it actually triggered the Canary token. So even if you put this in, you can see if somebody's trying to obfuscate the Canary token or trying to obfuscate the JavaScript. I don't know. I thought this was cute that it was able to actually pick up as soon as the code was obfuscated. But yeah, somebody clones your website. As soon as they start that website up in any fashion or another, you're going to generate an email alert saying that someone is up to some level of shenanigans on your system. Once again, this isn't hard. I mean, if we go back to Canary tokens, right? If you want to create a new token, you just basically select it. You're like, I'm going to create a token and cloned website, right? Then you can put in your email address, winnostrandjs@gmail.com. And then I'll put in a minor note, token, yeah. I think my Solar keyboard is not doing well. And I can put in thinkist.com. Or whatever, it doesn't really matter. And then I generate the token and I misspelled Thinkist. But there's your code, that's it. Copy it, paste it, drop it in, done. Once again, this shouldn't look like this is a tremendous amount of burdensome overhead for your organization. This is just crap that you do in a Friday afternoon when you're sitting around, you're like, hey, let's set some traps for bad guys. How does that sound? Let's do it. And away you go. So a lot of fun. Word documents. All right. Now, Word documents are one of those things that I would like to probably do a pull request with Canary tokens, kind of update the way that they're doing it. I'll explain that here in just a couple of seconds. Word docs are great, right? We can put them on shares, compromise computer systems. We can use the robots.txt trick, again, where we can say, don't go to that directory called help desk. And if you go to the help desk directory, you can have like all these documents that are like default passwords for local computer systems. And attackers are going to open those documents, right? You could send it as email to spammers. Somebody spamming you in a targeted attack for funds transfers. Then you send them back a Word document that has a beacon in it. You're like, well, in order for this to work, I need this form filled out, Mr. Big Shot, before I transfer the money. The attackers are going to do that, right? So there are some things that you need to keep in mind if you're actually going to fire up and create a callback Word document. So let's start with the basic one. With a Canary token, once again, this is probably one of the easiest Canary tokens to generate. So if I create a new token and I say, okay, Word document, we put in the email address. This microphone in my way is kind of messing me up. There we go. And then I can create the token. It's automatically going to create that Word document and pull it down. So we can open up that document right there. Let's see if it opens on my system. I actually don't have Word on this system. What do I have? It's probably going to generate some errors. There, it's Pages, right? So it has some missing fonts. That's okay. I don't care about that. But we opened up this document, right? So super easy. And then what you can do is you can put stuff in the document to make it look real. Like, you know, this is a real doc. Oh boy. There we go. Right? And then you can save it, and it still has the token built into it, right? It still has that particular token. You would want to rename it something like not evil, like that, and then save it. And there you go. Now you have your token with real docs in it. Hooray. And it's saved. And the problem with this, though, is, let me show you real quick. I don't think this one triggers. Let me refresh this. Yep, doesn't trigger, which sucks, right? I mean, we tried running it in Pages. What the hell? Well, it works in Word, right? So it works really, really well in standard Word. Now that would require the attacker to actually run Word. So here's a Microsoft Word trigger. We got the Canary token. We set a Word trigger, Microsoft Word. We have the source IP address and then the user agent string associated with that. So that's not that bad, but we can actually do a little bit better with our Canary tokens, right? We can do a couple of different things, and this is also why ADHD comes into play. So it will not work well with like Linux document processors, and ADHD has that capability. We actually have Word web bugs for that, right? So we can extend this out. So if we look at it within within ADHD, if you look here, cd into the opt web directory, into WebBug server. If you look at the templates that come with WebBugs, and this is created by Ethan Robish, you can do it in two different ways. You can put in a cascading style sheet, and you can also put in an image source tag. The advantage of doing it this way, using both CSS and an image source tag, the reason why that works so incredibly well, once again, all of these instructions are here in ADHD. So if we go to attribution, Word WebBug server, all of the instructions that I'm going through are all here to actually edit and create your document and have it trigger. Whenever you run it this way, the advantage of it is it'll trigger in Obby Word, LibreOffice, Apple TextEdit, Microsoft Word. It'll work in Pages. It works in just about everything, because these two additional ways of actually having a Word document beacon back work with more of these different word processors. Now, with some of them, they may generate an error, but even that's okay, right? Because by the time the error triggers, like in here in Obby Word cannot open this doc. It appears to be invalid. Doesn't matter. It's already beaconed back. So we have the IP address. We have the user agent string. We now have some level of attribution tracking on this. So that's really, really cool. Now, this whole idea can be taken even further, right? You can load this type of technology into Excel spreadsheets. You can load it into PDF documents. Once you start moving into the world of macros, and we might set up full creating Excel spreadsheets that do geolocation tracking in a webcast a little bit later using some techniques created by Chris Gates and Tim Tomes a while ago, we can put it in an Excel spreadsheet because macros tend to be executed by attackers in Excel spreadsheets far more often than they would inside of a Word document as well. So any questions on that? I'm going to now open up my questions because I'll be able to read them as well.
Yeah, John, does this generate any kind of alert on the attacker's Word, like when they open it?
On Word, see, here's the problem with Word. I don't have a Microsoft Windows system here. And this is something that Microsoft screwed up on. Microsoft got to the point with macros that anytime you download a new document, regardless of whether or not there's tracking in it, regardless of whether or not there's any macros in it, and by the way, the ones that I talked about with CSS and image source tags, those don't even require macros to be enabled. The problem with Microsoft now is every single time you open a document, it always pops an alert. It always pops up and it's like, do you want to enable this for editing? It might, got to be careful. And what that's doing is completely desensitizing anybody from any level of alert. So yes, it will generate an alert. No, it is not unique that there's something tracking in that document. It's the same alert that Microsoft Windows or Microsoft Word opens every single time on a document that opens.
And can you use them in an HTML formatted email?
Actually, you can. Here, let me show you actually what it looks like. Let's just go right to it because that's easier. Believe it or not, they are HTML formatted emails, not in emails. But yes, you can actually do it that way. So let's open up a terminal. If I cd, I'm just going to become root real quick. I got to find a better way of doing my mic in the future. It's WebBug server. There we go. So if we go into this directory, you can see the templates are right here. We got webbug.doc and webbug.html. And if I less out webbug.doc, oops, like that, it actually is clear HTML. And what's cool about this is if you fire this up inside of a Word document, Word is a browser. It'll actually trigger the HTML. It doesn't completely support like JavaScript and all kinds of things, but it does support some basic HTML constructs. So that's what the document actually looks like. So yes, you could actually load that into an HTML email as well. In fact, that is what a lot of mass mailers do. So if you're trying to do sales and marketing, if you've noticed BHIS's emails are always text. We did like last year, sent an email that had some tracking elements in it, and that was bad. I apologize. I'll never live that down. But we now just do plain text emails because we don't think it's cool to actually track people that are opening up your emails. But yes, email does actually support that capability as well. Another quick question, I'll answer this one real quick. Hold on. Somebody said, what can the attacker monitor the beacon? Yes, you can. If you're running Wireshark, you'll see a callback on that as well. Will this work on Mac for Word? Yes, it will work on Mac for Word. Where's the line of legality? So whenever you're talking about these tokens, if it's beaconing back, like I said, if you read the ruling in Absolute Software versus Susan Clements Jeffrey, that creates a really nice bright line for you as well. So check that one out. As long as you aren't getting persistent access, you're probably going to go okay.
Or unless taking anything from them.
Yeah, don't ever take anything from someone's computers. Good point. If they don't ever exit Microsoft's protected mode, they should be okay. Okay, crap, I should show this. No, it still beacons. So if you have the Word document, it opens, and it's like, hey, do you want to edit this? It beacons before the user clicks OK as well. There any integrations for Splunk? Not yet that I know of. Little Snitch? No, actually, this is cool. Little Snitch most likely won't generate an alert. And the reason why Little Snitch won't generate an alert is Little Snitch will generate an alert the first time that Microsoft Word opens. And you're going to be like, yes, Little Snitch. Trust Microsoft Word. And from that point on, Little Snitch is going to let it go. So by the time you open this document, odds are Little Snitch has already authorized Word to communicate background as well. Anyone going from KernelCon? Like to send us an email. It sounds like fun. I like kernels. Any ideas for mobile phones? So yes, some of these do actually work on mobile phones, but here's the problem. Almost every single mobile phone device that you run if you look at a document, it actually looks at it in Google Docs, if I'm talking about Google, and it doesn't beacon from the phone, but it beacons from the cloud service. So you'll be able to see that beacon back as well. How do you get around protected mode? Like I said, with protected mode, use Excel spreadsheets because people will allow that. And once again, the beacon, if it's just CSS, it's just image source tag, it'll trigger before they click accept as well. Never trust a Microsoft product in little snitch. Well, you got to do a job, right? So we have so many. I'm trying to keep up, Jason. I'm having a hard time. Best way to detect this on a blue team. We're going to talk about AI Hunter and Rita here in just a couple of seconds. Stick around. In general, do most or all honey tokens beacon before any error anomaly occurs that can get picked up? Yes, most all of them will beacon before the error actually triggers as well. What do you think of commercial Thinkist products? I'm just going to say, because this sucks, right? Because I have friends at Thinkist, I have friends at Elusive, I have friends at Ativo, I have friends at Symmetria, and they all want me to say, hey, their product is the best product on the face of the planet. I will leave you with this. Look at all of them. They all have amazing teams, amazing leadership groups. Look at all of them and find the one that suits your network the best. And then I'll let them fight it out first. This
John,
beacon's oh, go ahead. Yes.
I got an overall question for you.
Yeah.
Once you start using deception in your network, how do you let everyone else know that deception is being used so that the rest of your team isn't confused by what's happening?
One of the things about setting up deception technologies is you don't want to put it in a place where your general user population can find it. Like you don't want to say, well, here's our employee handbook and we've got deception technology in that. And then every employee reads that damn handbook. Your host. What you would want to do is create a share in your environment that is generally not something that users would go to. Let's call it top secret. And you put this share out, and that would be something that the attacker would be interested in. Name the document like passwords, something that PowerShell Empire File Finder will find automatically, but a general user will not. So that's the idea, right? You want to put this in places where your general user population will find it, but not sorry, let me reverse that. You want to put it in a location where an attacker will find it, but not your user population. I hope that answers the question.
Like the military analogy, don't put the claymores on your patrol trail.
That would be bad, right? Absolutely. Would scans like Nessus have issues with deployed honeypots? It depends on how the honeypots are actually implemented. If you're implementing a lot of these documents that call back, it's not going to be a problem for something like Nessus at all. All right. Any other questions that I should get to that you guys are seeing?
There's a bunch. I mean, we could do a bunch more webcasts. And speaking of, if you have ideas for future webcasts, drop them in the questions and we'll use them for the future.
Very cool. I think we should probably wrap it up. You're right. The questions keep coming. Yeah. It's almost like there's lots of questions. Check out the class at Black Hat. Check out ADHD. We have a lot of the stuff built into ADHD, and there's going to be a lot more webcasts on cyber deception and attribution, and a little bit on hacking back. So thank you so much for attending. So make him think his mic doesn't work. Shh, everyone hide.
Test. John, we lost you. Get it? Oh man, can you hear me? First.
It works.